I drew a rough sketch, and based on that, I used a 3D printer to create the food model. Let's take a look. The two pieces fit together perfectly. I'm preparing 440 alloy steel, which has great toughness and high strength, making it very suitable for the axe blade. The blueprint has been drawn, the glue is evenly applied, and the scraping is smooth. This dovetail structure can prevent the axe blade from disengaging from the sawing machine when it is stretched. Remove the excess part. The space in the middle is too small, so it can only be processed like this. Turn on the sand machine and grind the pots and basins that have been sawed around. The processing is smooth, and the outer shape is basically like this. Then use a file to grind it manually and remove the branches in the middle. Oh man, my hands are so tired, but I finally got it done. To make the connection between the axe blade and the axe handle even more secure, and to prevent it from falling off sideways, I decided to add a small accessory and connect them using argon arc welding. That should do it. It's definitely going to hold. Now, I'll put it in the electric kiln to heat it up, changing its structure. You can see it's already glowing red. I'll take it out, and then do a rapid cooling to increase the strength and hardness of the steel. However, it will also become more brittle, but that's fine. I'll be casting it later anyway, so it'll be tempered then. It looks a bit dark now. I did some sandblasting, and it turned out nice and white. Before starting the casting, I need to make a sand core for the floating eye using this mold. I'll mix sodium silicate into the sand and stir it well, then pack it tightly into the mold. Let's smooth it out and take a look. It's done easily. I'll place the model and add some release powder, then sprinkle on the casting red sand. For the core area, I can pack in some fine sand, and the rest will be filled with water. I'll smooth it out, place the cover on top, and tighten it with screws. Take it slow. Now I'll flip it over and set the other half of the model in place, sprinkling more release powder to make it easier to demold. The remaining steps are exactly the same. And once I'm done, I'll open it up to take out the two side models. Next, I'll carve out the pouring channel to control the flow direction of the molten copper. I'll place the axe blade inside, along with the white-haired axe handle, and make sure the sand core is set properly. Finally, I'll close the mold. The casting materials will use copper and aluminum, with copper making up 90% of the mixture. I'll load everything into the crucible and start by melting the copper. I'll light it up and cover it with the lid, while the aluminum block sits nearby. I think it's about ready. Now, let's toss in the aluminum block. It melted really quickly. I'll stir it with a carbon rod to mix it evenly. Alright, let's get the dry pot set up and stable. We need to clean off the slag floating on the surface. Hold steady and align it with the hole to push it in. Alright, it's all filled up. I wonder how it turned out. Let's open it and take a look. Wow, it's done. Phew. There are some defects. Look at this dovetail joint. There's a gap. When the molten metal comes in contact with the cold steel, it solidifies quickly, which causes it not to fill every corner. It has to be poured at an angle like this, and with Zhongli's help, it should fill up properly. The rods at the back can be used as welding rods. If there are voids in the casting made of the same alloy, you can use these to fill them. If different materials have gaps, then there's nothing you can do about it. In the morning, go to the bed, separate them again, and start over from the fairy tale. The servant puts it aside to preheat the cold cylinder. It should be fine to turn it into a hot cylinder. Place the lid back on tightly, and quickly pour in the molten copper. Take a look, it seems to be okay this time. The water outlet has been removed cleanly. To ensure everything is foolproof, use a hammer to cut the dovetail close to the total cut. Open the sandbag machine, and grind both sides of the joint. See if it is perfect. There is no wind at all. The eardrops are filled with enough strength to ensure that the structure is strong. I am afraid that the entire surface of the blanket needs to be polished to make it smooth. Look here. There is another side. It is full of sand holes. Fortunately, I made preparations in advance and poured solder. I just need to use argon arc welding to fill all the holes. It is easy to do, and make it smooth and beautiful again. Draw a line on the axe formation diagram, and use a height ruler to draw the center line. There will be no gaps when grinding if you don't cross the line. At the end, use fine sandpaper to slowly finish it off. Look at this effect. It really shines. This is truly a great piece of wrought iron for the axe head. I took a piece of walnut wood from the table to make the axe handle. First, I'll use a cutting tool to cut it to the right thickness. Then mark the position for the head, and use the table saw to cut it multiple times to get the right dimensions. In the horizontal push-pull process, smooth out the steps. First, get it to this stage. Then stick the template onto the saw bed and remove the excess parts. Start the manual processing by grinding the head, and then bring it over to test it out. Well, you can. Continue to sharpen the back, top, and tail of the axe handle. Next, I'll use some sandpaper to polish it a bit more. Then cut it open from the middle. Later, I'll need to grind the scorpion's eye as well, creating a taper so that the handle fits in snugly and doesn't come loose. Now let's start assembling it and give it a little heat. Then, stabilize it on the table and press the scorpion in. As long as everything is processed correctly, it won't come loose during use. Just remove the excess material. Finally, apply linseed oil for maintenance. A bronze steel blade axe with a dovetail joint is now complete. The axe blade has hardness, and the axe itself has toughness, combining strength with flexibility. It's truly perfect.